Hello and welcome to Algebra 2 Lesson 49. In this video, we're going to learn about multiplying and dividing rational expressions. So again, we've come across a topic that we learned back in Algebra 1, but we want to review this for the purposes of Algebra 2. Before we get into anything more complicated, we've got to make sure that we understand these topics that we learned in Algebra 1. So I want to start by saying that when we multiply or divide rational expressions, we follow the same rules as with fractions. So if I was to multiply two fractions together, let's say it was something like 1/4 times, let's say 4/7. Well, we would check between the fractions to make sure that they were simplified first. And if they are, then I would check to see if I could cross cancel. I can cancel this 4 with this 4. So that leaves me with just a 1 and a 7. So I'd have 1/7 or 1/7 as my answer. It's essentially the same process we're going to follow when we start multiplying and dividing rational expressions. So as an example, let's say I had n squared minus 3n minus 18 over 5n plus 15. And we multiply this by 8n squared minus 32n over n minus 4. So the first thing I want to do is I want to factor everything completely. And when I factor with these rational expressions, in a lot of cases, it's going to work out to where you can cancel between numerator and denominator, and then I can also cross cancel as well. So let's just start out by factoring everything. So I'm going to put my equal sign. To factor n squared minus 3n minus 18, I can factor that into the product of two binomials. I know this would be n and this would be n. And then I need two integers whose sum is -3 and whose product is -18. So we think about that, you come across -6 and +3. -6 plus 3 would be -3, and then -6 times 3 would be -18. So we put -6 and +3. All right, then we want to factor this guy right here. I would just look to pull out a 5, and that would leave me with what? An n plus 3. So you can already see before you go any further that I can cancel this factor of n plus 3 with this factor of n plus 3. Remember, this is multiplication, so these are factors. And these are factors. And we cancel common factors. All right, then times. Over here in the numerator, I can start by pulling out an 8n. So I'd be left with n minus 4. And then in the denominator, I have n minus 4. So you'll notice you can cancel a common factor here of n minus 4. And to make that obvious, put this in parentheses and put times 1. And then you'll realize this is a factor, and so is this. Or you could say these are both factors. These are factors as well. So you cancel those common factors. All right, so now that I have done that, I've canceled between numerator and denominator of each, I'm going to look to see, can I cross cancel anything before I multiply? So let me just rewrite what's left. I'd have n minus 6 over 5 multiplied by 8n. You could put over 1 if you want. So can I cancel anything between 5 and 8n? No, I cannot. Can I cancel anything between n minus 6 and 1? No, I cannot. So I can leave this in factored form and say this is 8n times the quantity, n minus 6, over 5. All right, let's go ahead and take a look at the next example. So we have a plus 3 over 2a plus 6. This is multiplied by 30a minus 48 over 64a squared minus 40a cubed. So again, I just want to factor everything. With a plus 3, I cannot factor that, so I'm just going to leave it as a plus 3. With this one, 2a plus 6, you know you could pull a 2 out. So you'd have 2 times the quantity, a plus 3. And obviously you can now cancel between the numerator and denominator this factor of a plus 3. I'm going to put times 1 here just to make that obvious for you that these are factors. Then times, over here I have 30a minus 48. So 30 and 48 share a common factor of 2 and also 3. So that means they each share a common factor of 6. So let's pull a 6 out. And that would leave me with 5a minus 8 inside. And then in the denominator, I have a 64 and I have a 40. So those are each divisible by 4. They're also each divisible by 8. That's about as best we can do. So let's pull out an 8 And then we have a squared and a cubed. So 8a squared is what we can pull out. So I'd be left with 8. Then you'd have your minus 5a. Now, we know we can do some canceling between here and here, but let's hold off on that for a second. I have 5a minus 8. I have 8 minus 5a. Those are opposites. If you'll notice, I have 5a and I have 5a. Forget about the sign for a second. I have 8 and I have 8. Each one has an opposite sign. Here 8 is negative, here 8 is positive. Here we have negative 5a, here we have positive 5a. So if you have opposites like that, essentially you can just cancel them and say the result is negative 1. If I was to do a little side note here and just show you this, I could take this right here. Let me just start with 5a minus 8 and put it in parentheses. I'll just put times 1 to make it completely crystal clear what's going on. For this one, let's just rearrange the order. Let's say this is negative 5a plus 8 like this. Now, let's say I factored out a negative 1 from here. So if I pulled out a negative 1, what would happen? This would turn positive, and this would turn negative. So now we have 5a minus 8 and 5a minus 8. This would cancel with this and leave me with this. I now have 1 over negative 1, which is just negative 1. So again, if you see that situation, you don't need to go through this long, lengthy process. I've got the same terms, but with different signs. I know those are opposites. So I can cancel this with this and say it's a negative 1. Now, I can do some more canceling if I want. I know that 6 and 2 have a common factor of 2, and I know 6 and 8 have a common factor of 2. So whatever you want to cancel that with, it's up to you. It's going to be the same in the end. I'll just cancel this 6 with this 2. I'll say this is a 1, and now this is a 3. So this right here is completely canceled. This is a 1. So I don't even need to worry about it. 1 times anything is itself. In the numerator here, I have 3 times negative 1, which is negative 3. In the denominator, I just have 8a squared. So my answer here is negative 3 over 8a squared. All right, let's take a look at one more of these, and then we're going to jump in and look at some division. I think you can see that it's pretty easy to do. It's just a lot of canceling, a lot of trying to get things simplified. All right, so we have 7x squared plus 73x plus 90 over 14x squared minus 22x minus 60. And this is multiplied by 2x minus 6 over 10x squared minus 40x. So the first thing I want to do is try to factor everything. And for 7x squared plus 73x plus 90, we can think about two integers whose product would be 7 times 90, which is 630, and whose sum is 73. I know that two such integers would be positive. Let's think about 630 for a second. It ends in a 0. So I know it would be 63 times 10. Now 63 and 10 add to be 73. So I've found my two integers pretty easily. Let's erase this. I'm going to use those two integers to rewrite this middle term here. So I'm going to say that we have 7x squared plus, I'm going to say we have 63x plus 10x plus 90. Again, I took this middle term, 73x, and I wrote it as 63x plus 10x. Didn't do anything illegal. Now I'm going to factor by grouping. So from the first group, I could pull out a 7x, and I'd be left with x plus 9. From the second group, I could pull out a 10, and I'd be left with x plus 9. So I could factor out this common binomial factor of x plus 9. And what's that going to leave me with? I would have x plus 9, that quantity, multiplied by the quantity 7x plus 10. And so let me erase this, and I'll write this in factored form. I've got x plus 9, that quantity, multiplied by the quantity 7x plus 10. All right, so let's work on the denominator now. In the denominator, everything is even, so I could start by just pulling out a 2. And I'd be left with 7x squared minus 11x minus 30. Now, how can we factor this? Well, give me two integers whose product is 7 times negative 30, or negative 210, and whose sum is negative 11. Well, this is another one. If I just think about positive 210 for a second, if I just think about 210, it ends in a 0. So I know it would be 21 times 10. So I could play with the signs with 21 and 10 and get myself a sum of negative 11 and a product of negative 210. If I had negative 21 and positive 10, that would do it for me. Negative 21 times positive 10 is negative 210. Negative 21 plus 10 is going to give me negative 11. So let me go ahead and factor this part down here. If I had 7x squared, I'm going to rewrite the middle term using these two. So minus 21x, and then plus 10x, and then minus 30. So let me scroll down for a minute. I'll come right back in a second. So from the first group, I can pull out a 7x. I'd be left with x minus 3 inside. From the second group, I could pull out a 10, and I'd be left with x minus 3 inside. So I would factor out this common binomial factor of x minus 3, and that would give me the quantity x minus 3 multiplied by the quantity. You'd have 7x, then plus 10. All right, so let's erase this part. We'll have 2 times the quantity x minus 3, then times the quantity 7x plus 10. All right, so let's erase all this. And we can see that we can cancel a common factor of 7x plus 10. That's canceled. Remember, this is multiplication. Those are all factors. So 2 is a factor, the quantity x minus 3 is a factor, and the quantity 7x plus 10 is a factor. These are factors. And then the quantity x plus 9 is a factor, and then the quantity 7x plus 10 is a factor. So we canceled common factors. Then times. For these guys, it's going to be easier to factor. Pull out a 2 from the first one, so I'd have x minus 3 inside. In the denominator here, I could pull out a 10x, and I'd be left with x minus 4 inside. So what can I cancel here? Well, I know between 2 and 10, I can cancel a common factor of 2. So this would be 5. I can now cross-cancel a factor of x minus 3 between here and here. So that's gone. And nothing really else that I can do. I have x plus 9 here. Nothing to cancel with that in my denominator or the denominator over here. This is completely canceled, so really nothing else I can do. So let's just put equals. We have x plus 9 for our numerator, that quantity. In the denominator, we have 2 times 5 times x, which is 10x, times the quantity x minus 4. And again, I'm just going to leave this in factored form because this is generally preferable. All right, so the next thing we want to talk about would be dividing rational expressions. So to divide rational expressions, multiply the first rational expression by the reciprocal, remember that means we flip it, of the second. All right, for the first problem, we're looking at negative 2a plus 2 over a minus 1. And this is divided by, we have 40 minus 5a over 5a minus 40. So if I look over here, what can I factor? Well, I can factor out a negative 2 or a positive 2. Because the sign here is negative, let's go ahead and factor out a negative 2. That's going to leave me with a minus 1 inside. Down here, I just have a minus 1. If you want, you can enclose this inside of parentheses and put times 1 so that it's crystal clear that you can cancel this with this. I'm left with negative 2 over 1 there. Then this is divided by, so that means I'm going to multiply by the reciprocal of this. So that means 5a minus 40 would come up to the numerator, 5a minus 40, and 40 minus 5a would go into the denominator. Now, before I go through and factor anything, what do you notice here? I have 5a and negative 5a. I have negative 40 and positive 40. These two are opposites. And again, if you want to switch the order around and say this is negative 5a plus 40, like that, and then factor out a negative 1 from one of them, it doesn't matter which one. If I factor out a negative 1, then I would erase these two signs here, put my negative 1 out here, so this becomes positive and this becomes negative. Because negative 1 times 5a is negative 5a, negative 1 times negative 40 is positive 40. So that would get me back to what I had. So now when you look at these two, it's obvious that this cancels with this. I can put it inside of parentheses and put times 1 if you want. And what I'm left with is 1 over negative 1, or just negative 1. So what I get for my answer here, I have negative 2 over 1, which is just negative 2, multiplied by 1 over negative 1, which is negative 1. So negative 2 times negative 1 is simply 2. And that's my answer. All right, let's take a look at another one now. So what we're going to do here, I'm going to factor the numerator of this first guy. And it looks like I can pull out a 7. So if I pulled out a 7, I'd be left with 7n minus 4. This is over 4n. And then I'm dividing by, so I want to multiply by the reciprocal. So bring 5n up here, and this is over. From this numerator here, it's going into the denominator, but I want to just go ahead and factor it. I can pull out a 5n. So I pull out a 5n, and I'll be left with 7n minus 4. So now what can I do? Well, it's obvious that I can cancel this 5n with this 5n. I can cancel this quantity 7n minus 4 with this quantity 7n minus 4. So this has canceled and become 1. So all I'm really left with is 7 over 4n. And so that's going to be my answer, 7 over 4n. All right, let's take a look at one more problem. So we have 6x squared plus 10x over 15x squared plus 13x minus 20. This is divided by 45x to the 4th power over 5x minus 4. All right, so from the numerator of the first fraction here, I know I could pull out a 2x. So that would leave me with a 3x plus a 5. In the denominator down here, I can't start by factoring anything out. 13 is a prime number. Nothing's going to be common. So I'm going to try to factor this using grouping. So 15 times negative 20 is negative 300. So I'd want a product of negative 300 and a sum of 13. So a sum of 13. When I think about factors of 300, let's just think about 300 for a second. I know they're going to have to be somewhat close together because it's going to be a sum of 13. So I'm going to exclude things like 1 times 300 or 2 times 150. I want to get kind of closer together. So if I just cut this off and say, I know it's 30 times 10, I can work from there, okay? Now 30 and 10 won't work, but I can decrease this one and increase this one. So the next two factors would be 25 times 12. Now 25 and 12, if I play with the signs, can produce a positive 13 as a sum and a negative 300 as a product. I would want positive 25 and negative 12. So let's use that to rewrite that middle term. So we're going to say this is 15x squared plus 25x minus 12x minus 20. Now let me erase this so we have a little bit of room to work. And I'll scroll down a little bit for now. So from the first group here, I could pull out a 5x. That would leave me with 3x plus 5. From the second group, I could pull out a negative 4. Both signs here are negative, both signs here are positive. So that's why I'm pulling out a negative along with that 4. So that would leave me with 3x plus 5 inside. And so I have a common binomial factor of 3x plus 5. So let's go ahead and factor that out. And we'll just write our answer above. So we'll have 3x plus 5, that quantity. Multiplied by the quantity, we have 5x, and then minus 4. All right, so let's erase all this. And we can already see that we could cancel this factor of 3x plus 5 with this factor of 3x plus 5. Nothing else to cancel between numerator and denominator here. Then we're going to multiply by the reciprocal of this. So 45x to the 4th power would go into the denominator. Nothing I can really do with that. In the numerator, I just have 5x minus 4. Nothing I can really do with that. Now, what I can do is I can cancel this with this. And again, if you're confused by that, just put parentheses around it like this and say it's times 1. Then you realize it's a common factor. The quantity 5x minus 4 is canceled with the quantity 5x minus 4. So all I'm left with here is 2x times 1, or just 2x, over 45x to the 4th power. Now, can I simplify this any further? Yeah, I can cancel one of these x's, this would be x to the 3rd now, with this x here. Between 2 and 45, there are no common factors other than 1, so I really can't do anything with that. So we'll end up writing this as 2 over 45x cubed.